Welcome to Sequences and Series. In this video, we're going to be talking about geometric series. So just a quick recap. Remember, a series is a set of numbers from a sequence that we add together. That's a series, right? But a set of something that you put together. That's exactly what a series is. So we have a set of numbers from a sequence. We put them together. So in this video, we're going to generally be talking about geometric series. So let's get right to it. All right, so let's first remind you what a geometric sequence is. So because, if a geometric series is adding the terms of a geometric sequence, then I think we need to talk real quick about what a geometric sequence is. So remember, a geometric sequence is simply any sequence that is exponential. So if the exponent contains your variable, you are exponential, which means you are geometric. So all four of these examples are geometric sequences. Now here is kind of the general formula that we give to find any term we want. You take the first term times the common ratio raised to the n minus 1. But again, be careful because you could always manipulate that form. But as long as the exponent contains your variable, you are exponential. So in this first example, we have 4 times 3 to the n minus 1. Pretty easy. If I said, hey, what's the fifth term? Well, you'd plug in 5. 5 minus 1 is 4. 3 to the 4th is 81 times 4. The fifth term is 324. Easy. Now, this next example doesn't quite look like our generic formula, but that's okay, right? It doesn't matter. Since the variable is in the exponent, we're exponential. So how do I find the first term? Well, plug in 1. 2 to the first is 2. That was easy. How do I find the fifth term? Well, plug in 5. 2 to the fifth is 32. There you go. Really, really simple. All right, now here we have another example. Now this time, we actually do look like our form. We have the n minus 1, which is what our formula has. Okay, that's great. But notice that we have a negative on that r. All that negative does is instead of multiplying by 1/2, multiply by 1/2, multiply by 1/2, we're multiplying by negative 1/2. And when you multiply by a negative, you start off with a positive, and then you become a negative because you multiply by a negative, and then you become a positive, and then you become a negative. So it just kind of alternates you. But again, don't fret. I tell kids, don't worry. Just listen. Follow what it says. If you want to find the sixth term, you plug in 6. So 6 minus 1 is 5. Now, when you do go to your calculator, I just really highly encourage you, you got to use parentheses. So if I'm going to type this into my calculator, I'm going to do 6, and then in parentheses, negative 1/2. And then again, raised to the, if I'm finding the sixth term, 6 minus 1 is 5. So there I go. I get negative 0.1875, which is a good answer, but you know how much I love fractions. So just hit math, change it to a fraction, negative 3/16. So there it is. So my term there was negative. Okay, easy, right? All of these are examples of geometric sequences. I just want to remind you what they look like. So now, how do we find a geometric series? Well, remember, a geometric series is just taking a bunch of terms from a geometric sequence and adding them together. But if you got 4 terms, you could do that. Just add 4 terms together. Bingo, bango, bongo, done. But if you have 100 terms, that's a lot of work. So of course we have a formula thanks to our buddy Carl Gauss. So here is the formula for the sum of a finite geometric sequence. So again, here's that general formula for a geometric sequence. But if we want to take the sum, and that's what this sigma stands for, if we want to take the sum of a geometric sequence, starting with the first term going to the nth term, this is a formula that can find us that sum very, very quickly. So instead of me having to add and add and add and add and add, I could just use this formula to get my summations. Really awesome formula. But before I explain it, you have to be geometric in order to use this formula. All right, here's how this formula works. So first we have the first term that we care about. Now it says a sub 1, which implies the first term, but you don't have to start with the first term. So I emphasize that this is the first term we care about. And then we multiply that by 1 minus r. Of course, r is your common ratio. 1 minus r raised to the n. And n is how many terms we're adding together. So you got to also be careful about that. You have to really take your time to think, how many terms am I adding together? So you do 1 minus r raised to n, and then you divide that by 1 minus r. That's it. It's easy. It's that easy of a formula. Now be careful. I just want to show you this. I love this formula. This is how I solve all the problems. But some people distribute that a sub 1, and they get a sub 1 times 1, which is a sub 1, minus a sub 1 times r raised to the n, and then they divide by 1 minus r. So obviously, again, guys, it's algebra, right? Algebra allows us to manipulate formulas to look different but not be different. So this is just another form of that same formula, but I actually prefer to use this one right here. That's the main one that you'll see me use in this video. So let's just jump and look at some examples. All right, so this first example wants me to add together the first term all the way to the 11th term. So now, listen. There's nothing holding me back from plugging in 1, plugging in 2, plugging in 3, plugging in 4, 5, 6, 7, 8, 9, 10, 11, and getting my final answer. But, you know, that might take a little bit of time. So this is where the formula comes in handy. All right, so the formula starts off with the first term you care about. And in that, according to this problem, that's plugging in 1. So if I plug in 1, 1 minus 1 is 0. 1 half to the 0 is 1. Anything to the 0 is 1. So that's going to be 1 half to the 0 is 1. 4 times 1 is 4. So the first term I care about is 4. All right, then in parentheses, I'm going to do 1 minus my common ratio. Now, the common ratio is 1 half. If you prefer to write 0.5 just because it's easier to write, that's fine, but be careful. If it was 1/3, I cannot do 0.33 because 0.33 is not 1/3. 1/3 is 0.3 repeating, so I'd have to write 1/3 there. But with 1 half, I'm okay with 0.5. And then I'm going to raise it to, again, this is where you got to be super careful. Right here goes how many terms I have. So 1 through 11 is 11 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 terms. So I'm going to reuse it raised to the 11th, all divided by 1 minus the ratio, again, which is 0.5. So pretty easy formula. But the tricky part is actually typing this into the calculator. Some kids have a very hard time doing it. So my thought process is go slow and use order of operations and use parentheses. So it's 1 minus 0.5 raised to the 11th. Hit enter. Now I'm going to divide that by, now you can do the 1 minus 0.5 in your head. I mean, that's really not that difficult. 1 minus 0.5 is 0.5. But again, if you are going to just type in 1 minus 0.5, use parentheses because you want to make sure that you're telling the calculator do the 1 minus 0.5 first and then that division. Okay, and then I'm going to times that by 4. Okay, there we go. Now listen, that's some ugly decimals, so I'm going to hit math and I'm going to try to change it to a fraction. And sometimes it cannot be changed to a fraction. If that's the case, then, you know, give me 3, 4, 5 decimals for safety. But if it can be changed to a fraction, you better believe I want it written as a fraction because that is much more precise. So 2047 over 2000 or 256. There is my sum. Easy. A lot easier than doing the first term plus the second term, right? So much easier. Okay. All right, let's try this next one out. Okay, once again, it is geometric, obviously, because the n is in the exponent. So that tells me it's geometric. So I could use this new fancy formula I found. All right, so here we go. First is the first term I care about. Well, be careful, because in this problem, the first term I care about is actually the 0th term. So to get the first term I care about, I'm going to plug in 0. 3 raised to the 0 is 1. Times 2 is 2. So there's the first term I care about, which is the 0. And that's why, look, let me just quickly go back to the formula. The formula calls for a sub 1. But again, you got to be careful. It stands for the first term you care about. And in this problem, the first term I care about is found by plugging in 0. Just be very careful, please. All right, 1 minus my common ratio is 3. Now, what do I raise that to? Well, it's how many terms I have. Now, this is where, again, you got to be careful. From 0 to 15 is 16 terms because 1 to 15 is 15 terms, but then I'm starting at 0. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 16 terms. all divided by 1 minus the common ratio, which again is right here, 3. All right, so when I go to my calculator, just be careful. 1 minus 3 raised to the 16th. Get that answer. Divide by, now listen, I could do the 1 minus 3 in my head. 1 minus 3 is negative 2, so divide by negative 2. And then times by 2, and oh my gosh, do I get a big number here. I might have to go back and forth a couple times. 43046. 43046,720. Let me double check. 43046,720. Yep, an absolutely enormous number. And hey, it is what it is. The formula got it for me. It's really an easy formula, but I stressed this in the previous video with the arithmetic series. It's an easy formula, but you got to know how to use it. Let's do 2 more examples. Now, I chose these examples because they involve some weird numbers, but again, weird numbers don't matter. All right, here we go. Is this geometric? You better believe it, because the exponent contains my variable. That's exponential, which makes it geometric. All right, so again, I'm going to start off with the first term I care about, and according to this problem, the first term I care about is plugging in 1. 1 minus 1 is 0. 0.78 to the 0 is 1. 1 times 4 is 4. All right, then I need 1 minus my common ratio, 0.78. And then again, I'm going to raise that to the number of terms. So how many terms are there? 1 through 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 terms. And I'm going to divide that by 1 minus my ratio of 0.78. All right, now I'm going to go to my calculator, and again, I'm going to be very careful. 1 minus 0.78 raised to the 12th. And I'm going to divide that. Now, once again, you can do it in your head. 1 minus 0.78, again, feel free. If you're confident, is 0.22. But if you're not confident, you just got to use parentheses, 1 minus 0.78. Because you got to make sure the calculator does that first. And now we get 4.3149. Okay, great. Times that by 4. And, okay, there we go. Try to change it to a fraction. And, oh, it works. Again, sometimes it doesn't work. In that case, you got to give me decimals. But if it can be changed to a fraction, boy, oh boy, would I like you to do that. So I get 107,321, 107,321, all divided by 6218, 6218. Now, some kids will say, they'll put like the approximation, and they'll say that's approximately 17.2597. I'm okay if you put both fraction and decimal, but if it can be a fraction, we like to make it a fraction. It is what it is. All right, pretty nice. But again, it's kind of an ugly answer, but that's what you get when you have a ratio that's not such a nice number. Okay, whatever. What are you going to do? All right, here we go. Next example here. Once again, I'm going to start with the first term I care about. Red flag. First term I care about in this problem is the 5th term. So this is where you might actually have to do some math first just to find that 5th term. So I'm going to plug in 5. So I get 2 times 1.05 raised to the 5th. Again, I'm doing this just to get that first term, which, again, the first term I care about in this problem is 5, the 5th term. So I get 2 point, again, try to make it a fraction. And yeah, sometimes it just can't be made a fraction. So to be honest, I'm okay if you write 2.5526, but you know what? The first term I care about is 2 times 1.05 to the 5th. To be honest, that is exact. So excuse me, you could just leave that for now. That way when I go to use my calculator at the end, I actually take all of those decimals instead of rounding. So again, listen, this is the same thing as writing it down. It's just getting the exact answer, that's all. All right, then in my numerator, it's going to be 1 minus my ratio, 1.05, raised to the, well, again, let's be careful. How many terms are there? 5 to 18. Well, I'm starting with 5, so that means I don't want 1, 2, 3, and 4. So 18 minus 4 is 14. So there's 14 terms. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's 14 terms. Again, I don't want 1, 2, 3, and 4. So 18 minus 4 is 14 terms. All right, divided by 1 minus 1.05. All right, so when I do go to my calculator, like one thing I could do right away is, again, look, I kind of have that number right there. That was the 2.5525. That was the 2 times 1.05 to the 5th. So if I kind of leave that there, here's what I can do. I can do 1 minus 1.05 raised to the 14th. Hit enter. Divide that by, Now, again, you can do this in your head if you want. 1 minus 1.05. If you're good enough to do that in your head, it's actually quite easy. 1 minus 1.05 is just negative 0.05. So if you want to divide by negative 0.05, that's fine. Or again, if you are going to type in 1 minus 1.05, just use parentheses. And then now, watch what I'm going to do. I'm going to times that by, now I could times that by, here, I'll just do this, right? I'm going to times that by 2 times 1.05 raised to the 5th, which again was my first term I cared about. So instead of using the decimals, I'm using the exact answer, that's all. And I get 50.0267. Try to make it a fraction, but again, like I said, sometimes it just can't be made a fraction, especially when you got these crazy decimals. So in this case, I'm just going to round the 4 decimals, 50.0267. Just read the problem, right? If you're doing this in Delta Math or in my classroom, read the directions and it'll tell you how many decimals I want. That's all. All right, let's do a couple more examples. This time, I'm not using summation notation, right? This example just has the sequence listed. All right, well, no big deal. We can always turn this into summation notation, right? Which is actually a good skill to practice anyway. So here I go. All right, so I want me to find the sum of the first 10 terms. Okay, so that's the sum of the first all the way through the 10th term. All right, now all I need is a formula to find any term I want. So I call this my dirty work. I'm going to do some dirty work to figure that out. Well, again, the formula is the first term, which is 2, times my common ratio raised to the n minus 1. Now, what the heck is my common ratio? Boy, with decimals, it's sometimes hard to see. Don't panic. To find the common ratio, all you got to do is take the second term divided by the first term. And there you go. My common ratio is 0.7. Now, just to confirm this, you could take the third term, 0.98, and divide it by the second term, 1.4. And, hey, you get that common ratio of 0.7. That proves that it really is a common ratio. So there is my common ratio of 0.7. So now back to my summation. I'm going to do 1 through the 10th term. And my formula is 2 times 0.7 raised to the n minus 1. All right, so now, again, I could list all the terms and then add them, but again, I'm going to use my formula. All right, so the very first term I care about is the first term, which is 2. I know that because it's listed right here, or I could actually plug 1 in. 1 minus 1 is 0. 0.7 to the 0 is 1. 1 times 2 is 2. All right, easy. All right, then I'm going to follow my formula. It's 1 minus my ratio raised to the number of terms. I clearly have 10 terms, 1 through 10, all divided by 1 minus my common ratio of 0.7. All right, so now I'm just going to go to my calculator. Be very careful. 1 minus 0.7 raised to the 10th. Hit enter. Divided by, now again, 1 minus 0.7, I can do that in my head. That's 0.3. And then I'm going to times that by 2. And try to make it a fraction. Can't happen. Oh, well, it's got a bunch of decimals. Sometimes when you get so many decimals, it's hard to make it a fraction. So whatever, 6.4783. 6.4783 is the sum of the first 10 terms of this sequence. Awesome. Great. Easy. Let's try another one. All right, find the sum of the first 7 terms. Okay, well, let me write my summation notation first. They want me to start with the first term. That's right here. And they want me to end with the 7th term. That's somewhere down this line. All right, so now real quick, let me come over here and do my dirty work. Let me find my formula. So I'm going to take the first term, 2, times my common ratio to the n minus 1. The only problem is, what the heck is my common ratio? Well, how do you find the common ratio? Take the second term divided by the first term. Or take the third term divided by the second term. Or take the fourth term divided by the third term. Now, you don't have to do it 4 times or 3 times, but once you realize, oh my gosh, the common ratio is negative 3.5, because that's the idea. It's a common ratio. If you take any 2 consecutive terms and divide them, you get that same number. That's the sign of a geometric sequence. So it's negative 3.5. All right, so here I go. Let me go back to my summation notation. So I'm adding up the first through the 7th term. of the formula 2 times negative 3.5 to the n minus 1. Now I just got to use my formula. So again, it starts off with the first term. The first term I care about is the first term, which again, I could look to see that it's 2. Or I could plug 1 in. 1 minus 1 is 0. Negative 3.5 to the 0 is 1. 1 times 2 is 2. And then now you got to be very careful with this, right? Definitely need parentheses. So it's 1 minus negative 3.5 raised to the 7th, because I'm adding 7 terms, all divided by 1 minus negative 3.5. Now listen. In the denominator, I could change the minus and negative to a positive. Well, that's going to be 1 plus 3.5, or in my head, that's 4.5. But you cannot do that right here in the numerator, because this is not 1 minus a negative. It's 1 minus a negative to the 7th. So again, you got to follow the order of operations, which means to do the exponent first. But listen, if I use my calculator properly, I don't have to worry about that if I use my calculator properly. You need parentheses around that negative number. So that way the calculator knows what to do. So again, there's the numerator. Boom. Divided by, now listen, you could do that bottom in your head. 1 minus negative 3.5 is 1 plus 3.5, which is 4.5. And then I'm going to times that by 2. Try to change it to a fraction, but with so many decimals, not going to work. All right, so my final answer is 2859, 2,859.9688. All right, there we go. Ugly, but when you got a bunch of decimals, ugly is kind of what you get. But again, I'm following my formula. Can't go wrong. All right, let's try another example here. And this time, again, it's a very similar one, but this time it says find the 25th partial sum. So first, understand that a 25th partial sum is just a fancy, very colonial way of saying find the sum of the first 25 numbers. So that's exactly what I'm doing. Find the sum of the first 25 terms of this sequence. Now, let's go ahead. Is this geometric? Well, we're in the geometric lesson here, so yeah, it's geometric. But, how do you know for sure it's geometric? That's where you got to do your dirty work. So the formula for any term is the first term 1/2 times my common ratio to the n minus 1. So the question is, what the heck is my common ratio? Well, divide any two terms. So take 3/2. That's the second term, divided by 1/2, the first term, and boom, you're going to get your common ratio. Now, just to confirm, take the third term, 9/2, divide that by the second term, 3/2, and voila, you get the same common ratio. So that's my common ratio of 3. So there's my formula, 1/2 times 3 to the n minus 1. All right, now I'm ready to use my formula to find the sum of the first 25 terms. I definitely don't want to do that by hand. All right, the first term is, well, it's right there. It's staring at me in the face, 1/2. Or, again, I can plug in 1. 1 minus 1 is 0. 3 to the 0 is 1. 1 times 1/2 is 1/2. And then on the numerator, I have 1 minus my common ratio raised to the 25. 25 total terms, 1 through 25, divided by 1 minus the ratio of 3. Go to my calculator. Be just careful. 1 minus 3 raised to the 25. It's going to be a big negative number. But then I'm going to divide that by 1 minus 3 is negative 2. Got it? Times that by 1/2. So times by 0.5. 0.5 is 1/2. And now be very careful. You could try to change this to a decimal, but not going to happen. Now notice this number. It's 2.11. But then don't forget, this number is getting bigger and bigger. I'm multiplying by 3, multiplying by 3. So this number is going to get big fast. So again, notice it says e to the 11. That means I got to move the decimal 11 times to the right. So if I move it 11 times to the right, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's actually 3 more zeros. So this is 2, 1, 1, 8, 2, 2, 1. I'm bad at remembering numbers, so I got to keep going back. 5, 2, 4. And then I got to add on 2 more zeros because, again, I had to move that decimal 11 times to the right. This number is absolutely enormous, but that's because I'm getting big fast, right? 1/2, 3/2, 9/2, 27/2. It's going to get huge. It's going to get big really, really, really fast. All right, let's do just a little bit more here. All right, next example here is to write in sigma notation and find the sum. So I love this type of problem. Now, first off, is this geometric? Yes, I'm multiplying by 3, multiplying by 3, multiplying by 3. 5 times 3 is 15, times 3. Okay, so again, let's figure this out. So I'm doing a summation notation starting with the first term. There's the first term right there. A formula to find any term I want is the first term times the common ratio to the n minus 1. So there's my formula to find any term I want. And again, it's pretty easy to see that because the first term is 5, and then I'm timesing by 3, timesing by 3. You see that pretty easily. Now the question is, where am I going to? Like, it had a bunch of dots here. So it's like first term, second term, third term, all the way to this term. But I don't know what this term is. So this is where I got to do a little bit of math work to figure out what that term is. So again, I'm going to take, here's how we do this. I just got to do some algebra. So I know the term value, but I don't know the term number. So all I'm going to do is set the term value equal to my formula, and then what I could do is I could solve for n to figure out what that term is. And this is where we got to be very careful because the math is kind of tricky. So the first thing I'm going to do is I'm going to divide by 5. So I'm going to do 2, 9, 5, 2, 4, 5. Divided by 5. I'm going to divide that 5 over, and I get 59049. 59049 equals 3 raised to the n minus 1. So the question is, how the heck do I solve for n? Well, logs. I know it's been a while, but we did learn about logs. So I have to write this as a logarithm. Remember, logs equal exponents. So log base 3, that's my base, of 59049 equals the exponent of n minus 1. So again, this is just turning the exponential notation into logarithmic notation because logs equal exponents. So log base 3, 59049 equals n minus 1. And at this point, all I got to do is add 1. So n equals log base 3 of 59049 plus 1. I'm just adding this 1 over. So I'm going to come to my calculator, math, go and grab your log base. So this is log base 3 of 59049. Forgot the O, sorry. 049. And then again, outside those parentheses is where you add the 1, right? Not inside. Outside, because I'm taking the log and I'm adding 1 outside of that log, and I get 11. Wow, who would have ever thought? But what a nice number. So this is actually the 11th term, so that's what is going to go up on top here. So there is my 11th term. So essentially, I'm finding that all I want to do here is find the sigma notation. So I'm going from 1 to 11. That's why I found out this is the 11th term. So here I go. Now watch how easy it is to use the formula. Right? Using the formula actually wasn't the hard part of this at all. So again, the formula says the first term I care about is 5. 1 minus my ratio 3 raised to the 11 terms, divided by 1 minus 3. So again, I just needed to figure out what term that was so I know what exponent to put right here because that's the exponent. It's how many terms you have. So now I'm going to go to my calculator. 1 minus 3 raised to the 11th. Probably going to be a really big number here. I'm going to divide that by negative 2. I did the math in my head. 1 minus 3 is negative 2. And I'm going to times that by 5. And I get 442,865. 442,865. How crazy awesome is that? There you go, guys. Geometric series. Infinite geometric series. It's a pretty easy formula. You got to be careful, man. You got to be careful with that formula, guys and gals. It's a very simple formula, but you got to know how to use it. And then it becomes pretty easy. All right, hopefully you like these examples and get ready for some practice.